Good morning, dear students, and welcome back to our today's online class. In our previous class, we learned about the laboratory preparation of hydrogen gas, and we learned how to prepare hydrogen gas by using zinc granules and reacting it with either dilute hydrochloric acid or dilute sulfuric acid. We also learned the advantage of using zinc granule over pure zinc cubes or pure or even zinc powder, because zinc granules contains impurities such as copper, which acts as catalyst. We also learn how to purify hydrogen gas produced by the laboratory method. I told you some precautions in our previous class that we must follow in order to prepare pure hydrogen gas in the lab. Today I will add a few more precautions, okay? And that is, we should not use concentrated sulfuric acid to prepare hydrogen gas. That means we have to use dilute hydrochloric or sulfuric acid only. The reason behind that is concentrated sulfuric acid is a strong oxidizing agent, and it will oxidize hydrogen to water like nitric acid. So zinc reacts with sulfuric, this is concentrated sulfuric acid, and it will not give hydrogen gas as one of the product. Instead it will give salt, zinc sulfate. It will give another gas, sulfur dioxide, and water. So this hydrogen gets converted into water due to the oxidizing nature of concentrated sulfuric acid. Another precaution that we have to take is, we learned that the hydrogen gas need to be dried finally, because water vapor might be there during the collection of hydrogen gas. So that water need to be removed in order to get pure hydrogen. And we learned yesterday that we use drying agents such as fused calcium chloride, caustic potassium, etc. to dry the gas collected. Now we have also learned in our earlier chapters that sulfuric acid is also a good drying agent. Okay, so we can use concentrated sulfuric acid also to dry the hydrogen gas produced, but in this particular case we do not use concentrated sulfuric acid as a drying agent in the collection of hydrogen gas. The reason behind that is, concentrated sulfuric acid reacts with the hydrogen gas collected. Thus, the very purpose of producing hydrogen gas in the laboratory becomes failure. So sulfuric acid, concentrated sulfuric acid is a good drying agent, but in this particular case, if we use concentrated sulfuric acid, then that acid itself reacts with hydrogen and produces water and sulfur dioxide because of the oxidizing nature of concentrated sulfuric acid. So these two also we need to remember as precautions. Okay, apart from these two precautions, there are other precautions which are mentioned in the book, okay, which are small minute precautions which we have to take, like the apparatus should be airtight, there should not be any leakage of gas, there should be no flame burning near the apparatus, because hydrogen is a combustible gas. So if we light any fire near the apparatus, the hydrogen gas produced might catch fire and break our apparatus. Okay, we should not use concentrated nitric acid to make hydrogen gas that we discussed earlier. Now in our today's class we are going to see another method by which we can manufacture hydrogen. And this is a large scale production of hydrogen gas, or in other way we can say it is an industrial method of producing hydrogen gas. The name of this process is called Bosch process. So today we are going to see how we can produce hydrogen gas through Bosch process. So Bosch process. So in this process we need two reactants or two substances to start the reaction. First one is we need hot coke, okay, which is something around which must be around 1000 degrees Celsius, and we also need steam. So hot coke and steam are the two reactants in the Bosch process of manufacturing hydrogen. Now what do we have to do? Now we have to follow some steps, so we will discuss those steps one by one. Now first step in the Bosch process is to pass hot steam over hot coke at around 1000 degrees Celsius. So when we pass steam over hot coke at around 1000 degrees Celsius, we get water gas. We have done this particular reaction or learned about this reaction in the preparation of hydrogen by reacting with water. We have done this in our basic preparation of hydrogen gas. So the same method is going to be used over here in Bosch process. So when steam is passed over hot coke at around 1000 degrees Celsius, we get water gas. And what is water gas? Water gas is a mixture of carbon monoxide and hydrogen gas. And this reaction is endothermic in nature, which means it absorbs all the heat energy. Therefore, we don't get heat energy. Instead, we get all the heat energy are absorbed in the reaction. That's why we put minus. This pyramid sign is for heat, and this minus denotes that heat energy is being absorbed by the reaction. So this step is an endothermic reaction. Now once water gas is produced, now we move on to second step. Now in the second step, the water gas produced is mixed with excess steam and passed over heated ferric oxide, something around 450 degrees Celsius. Over here, this heated ferric oxide acts as catalyst. So this ferric oxide acts as catalyst. So this is a catalyst. And we all know catalyst increases the speed of reaction. Now, as a result of which we will get carbon dioxide gas and hydrogen gas. So we'll get two gas, carbon dioxide as well as hydrogen gas, along with heat energy which is being produced. So over here in the second step, heat energy is produced, it is given out, and which is denoted by plus sign. So heat is also one of the products. So heat energy is produced, and the reaction in which heat energy are produced or given out are called exothermic reaction. So our second step is exothermic reaction. First step was endothermic reaction, second step is exothermic reaction. So what do we have to do in the second step? The water gas which is produced in the first step has to be passed over excess steam using catalyst ferric oxide at around 450 degrees Celsius, as a result of which we will get two gases, and they are carbon dioxide and hydrogen gas. Now after this we move on to third stage. Now in the third stage, now remember what were the two products that were produced in the second step? Carbon dioxide and hydrogen gas. And this is a process or method to prepare hydrogen gas. So we don't need carbon dioxide gas. Therefore, what do we need to do? We need to remove or separate carbon dioxide produced as a byproduct. Now, carbon dioxide can be removed or separated by two ways. So let us discuss those two methods. Now, firstly, carbon dioxide gas can be separated from the mixture of carbon dioxide and hydrogen by forcing the mixture to pass through water, cold water, under very high atmospheric pressure of something around 30 atmosphere. Now, under this condition, cold water and very high pressure, carbon dioxide dissolves nicely with water because carbon dioxide has more dissolving capacity compared to hydrogen in water. So carbon dioxide will dissolve in water. Very few hydrogen will dissolve in water, but major portion of the hydrogen gas will leave the water. Thereby the carbon dioxide gets separated from hydrogen gas, and the gas which evolves will be hydrogen. So this is one method by which we can separate hydrogen or carbon dioxide from the mixture and get pure hydrogen. There is another method by which we can separate carbon dioxide from the mixture, and that is by passing the mixture of carbon dioxide and hydrogen through caustic potash solution. Caustic potash stands for potassium. Okay, caustic stands for alkali hydroxide. So caustic potash, so potassium hydroxide. When the mixture is passed through caustic potash solution, only carbon dioxide reacts with caustic potash. Hydrogen does not react. So carbon dioxide reacts with caustic potash, producing potassium carbonate solid and water liquid. Now we have here solid and liquid. But when we pass over here, when we start this reaction, we have a mixture of carbon dioxide and hydrogen, and both are gases. Now when we pass this mixture to potassium hydroxide or caustic potash solution, out of these two gases only carbon dioxide reacts with caustic potash, producing solid potassium carbonate and liquid water, whereas this hydrogen gas do not react, and therefore it will come out from the solution as gas. This is another method by which we can separate carbon dioxide from the hydrogen gas. Now, sometimes when we carry this process, separating process, some of the carbon dioxide, they produce carbon monoxide. They don't wholly convert into potassium carbonate. Some of the carbon dioxide break down to form carbon monoxide. That means another gas will be produced. Therefore, it becomes necessary to remove this carbon monoxide also from the mixture, and that can be done in the fourth stage, and that stage is separation of carbon monoxide. Now, to separate carbon monoxide from the mixture, what do we need to do? We need to pass the mixture of carbon monoxide and hydrogen through ammoniacal cuprous chloride solution. Ammoniacal containing ammonia, cuprous means containing copper, and chloride means chlorine solution. Okay, so when we pass this ammoniacal cuprous chloride or this carbon monoxide and hydrogen gas mixture through ammoniacal cuprous chloride solution, then carbon monoxide reacts with cuprous chloride and water to produce a complex compound. So this is the reaction which carbon monoxide undergoes. So this carbon monoxide reacts with cuprous chloride and water, producing a complex compound, and this is solid in nature. Thereby, the final gas which comes out from this solution will be the pure hydrogen. So finally, after completing the fourth stage, we will get pure hydrogen. And this hydrogen gas comes out of the solution in the form of bubbles, and that will be the pure hydrogen gas. So this is how we prepare hydrogen gas by Bosch process, and this is also called industrial method or large scale preparation. Okay, there is another method, easy method, by which we can make hydrogen gas, and that is electrolysis of water. Now you can also do this experiment at home. Okay, this electrolysis method of preparing hydrogen gas is not there in your syllabus, but you can always go through your book, see how we can carry this electrolysis of water to get hydrogen gas. The benefit of electrolysis method is, instead of only one gas, hydrogen gas, we can also get another gas, that is water, or I'm sorry, oxygen, because water is made up of hydrogen and oxygen. So electrolysis of water, so water, H2O, the composition of water is hydrogen and oxygen. So when we pass electric current through this, this breaks down to give us hydrogen gas and oxygen gas, like this. So this is also gas, this is also gas. So if we balance this over here, this will be 2 and 2. So we get 2 molecules of hydrogen gas and 1 molecule of oxygen gas when we break 2 molecules of water. This is electrolysis method of preparing hydrogen gas, which is not there in your syllabus, but you can always refer or try to know how we can prepare hydrogen gas by electrolysis method. So this much for today, boys. Please go through the reactants, conditions, and practice writing chemical equations for all the steps. Stay safe and do all things well.